So good evening everybody. So let us start our class tonight with some reminder. So if you go to the course schedule on the first year experience page, and this is our course schedule, and you see that there are some quizzes due by this weekend. Okay, so 4 quizzes: policy quiz, syllabus quiz, and quiz 1 review and quiz 2 review. Okay, all 4 quizzes are due by this weekend, Sunday midnight. Okay, so I will not be able to give you any extension. If you miss it, please do not miss it. Okay, and then hopefully from next week, and we will start a new topic, object-oriented programming. But you see that you have it first test 1, that will cover until tonight topics. What we discuss, we will discuss until tonight. Okay, and the test will be one here on Tuesday. Okay, test will be on Tuesday. No, Tuesday, that will be on 29th. 29th. Yes, please do not miss. Okay. Oh, sorry. Why it's not working? Okay, so let us start our lecture tonight. We have to cover 2 PowerPoint slides tonight. Okay, so please give attention. Okay, so in this class, you are coming for this class, you are paying for this. Even if you do not pay, someone else for you, maybe your parents or someone your beloved is paying for you. Okay, so if you come in this class and spend your time just for playing games, then it will not be a wise decision. Okay, I think everybody is mature and enough, so you should know what to do and what not to do. So in our last class we went through until lecture 2, slide 2, right? Okay, so now we will go with lecture slide 3. This is about searching and sorting algorithms. So everybody see that, right? Okay, searching algorithm and sorting algorithms, these are actually mainly based on a large data set that we call array, a list of similar data. Okay, searching is used to find whether an element exists in a list or not, and sorting means rearranging the elements of a list either in ascending order or in descending order. So I think everybody knows this, and then we have discussed this in your previous class. Okay, so just I will go through this quickly, but at any point if you have any question, please let me know. So searching algorithm is apparently easier than sorting algorithms. Okay, so for instance, for the worst case in a searching algorithm, for instance, if the element does not exist in the list, then you have to search all the elements one by one, right? Until starting from the first element, second element, third element, all the way nth element. Okay, or it may happen that the element exists, but it exists at the end or bottom. The element is the last element of your list. In that both situations, Okay, searching and solve like this searching algorithm, searching process goes in worst case and it takes log big O n. It's called its complexity is measured as big O n complexity. That means in the worst case it takes n iterations. Okay, but for in our class or in our demo program, we will be working a small data set, 10, 20, 30, 100, right? So we do not realize that effect of big O n. That means how long it takes. But in case of very large data set, like Walmart sales per week, or the whole total population of USA, drivers of owners of vehicles in the USA. In that list, in such kind of list, there is huge data. In that case, okay, in that case, you may realize that the effect of big O n, that if your elements exist at the end or if it does not exist, then how long it will take. You may realize that. Okay, the searching algorithm is pretty easy. Okay, so maybe in tonight's class or if I do not have time in next class, I will go through a real program, live program. So here in this case it says for each element in a element temp in G is my array or list. If temp equal to find means equal to that whatever element I will be finding. If I find it, then I will return true. Otherwise, I will return false. So this is called linear search algorithm. It searches all the elements one by one, starting from the top. It goes to the next element at the end, through the end. Okay. This is the C# programming program snippet, and this is a Java program snippet. It's pretty simple. I think everybody knows this, but if you do not understand, so please let me know. Okay, but there. Okay, so there is another efficient algorithm, searching algorithm, that is called binary searching algorithm. Okay, that takes apparently very few iterations, but there is a restriction that in binary search algorithm process your list must be in a sorted order, must be pre-sorted. If it is unsorted, then you cannot use your binary search algorithm. The binary search algorithm, the process is here is big O. You see big O log n. That means here you may need like this big O log n iteration. So for maximum type of, for instance, let us go through what is made by big O n. Actually, if you have 1024 elements in a list, okay, so the binary search algorithm will make it half, in a fast search. Okay, then your size will be reduced to 520. Then in the next iteration it will be reduced to another half, then it will be 256. Okay, and another iteration it will be again reduced to half, 128. Every time it gets twice, half. Okay, then C64, and then how many times it needs? Maximum 10 iterations, because 2 to the power 10 equal to 1024. Okay, like this dot like it will come to 1. Okay, in this is why it is called big O n. Its base is 2. For this logarithm, base is 2. So let us see this with a pseudocode. This is a pseudocode. Okay, this pseudocode actually we see that we are getting low index, actually low index. Initially low index is 0 and we are getting high index. High index is the number of elements in the array. Actually should be -1. Actually high index we will get. Okay, then we can find the mid index. Low plus high divided by 2 is an integer index. Then we can find the element when we have the index of an array. Then quickly we can find I'm looking for if I have a code. We can find the element of that index position. Okay, so if my elements of this position is called, it is called G of mid. G is my array list over here. Then if it matches with my targeted element, then we return true. Okay, otherwise if it goes let me see which version I did open. Sorting. Maybe I opened a wrong file. I got two. Okay, actually I need to open this one. Okay, so I have some some picture over here. This shows that I have my low index is equal to 0 and high index is the last index. So if I get my high index and low index, then my middle index will be calculated as low index. What is the algorithm? Low index plus high index divided by 2. This will be an integer number. So then when I find my middle index, then I can find the value at that position, middle position. So then, for instance, let us consider that we will search for 20, whether 20 exists in this list or not. So then, when we find our middle element 20, middle element 35, that is greater than 20, and we know that for sure that our list is a sorted list, right? So in the next phase, we do not need to go to the upper side of this middle, upper side, right? So because we are sure that our targeted element 20 is since less than 20, if it is less than 35, so then we will change the higher index, we will shift the higher index to the middle position, and we will recalculate the middle position. But if it happen that if our targeted element would be here in this position between middle and higher, then what we would do, we would move our lower value, lower index to the middle, and we would recalculate the middle. Okay, so since our 20 is less than 35, so we will move our higher to this middle position, 35 position, and we will recalculate middle. Okay, so middle will be this 0 plus 1, 2, 3, 4, 5, 6, 7, right? 0 plus 7 equal to 7 divided by 2 equal to 3, not 3.5 integer. So 0, 1, 2, 3. So the third value will be 15. So in this case we will see our targeted value 20 is greater than 15. So we will move our lower index to the middle position and we will recalculate our middle. Okay, at this point, at another position, another step, we will see our lower index here is 3 and higher index is 7. So 3 plus 7 equal to 10 divided by 5 equal to, 10 divided by 2 equal to 5. So then next time our middle index will be 5th position. Okay, and then we will find our targeted value, find the value at middle position, that will be 20, and we are getting match 20 equal to 20. So then element is found. But in that case, if we do not find, or some case if we get lower value equal to higher, lower index equal to higher index, then we will stop. Anyone has any questions? Okay, the binary search algorithm is pretty efficient because every time it slices the list into two halves, right? And it throws out one half and keeps half, the useful half portion, okay, useful portion. So it is pretty useful, but the limitation is that your list must be pre-sorted. If you are for sure that your list is sorted, then you can use binary search algorithm. Okay. So searching algorithm, this is another tracing of binary search algorithm. You can go through. Okay, and then I have added my slide also on D2L. You can download my slide, and also you can follow both. Okay, actually this is a big O notation. It's called the complexity. Okay, the worst case in binary search algorithm will be big O n log n, big O log n, and the best case is that it may happen that you may find your targeted element at the first search. It may happen. So in that case, it's big O 1. That means 1 means constant. So if you are lucky enough that you are getting your element at the first search, the first try, then your time will be required is big O 1. This 1 means constant value. It could be a millisecond or microsecond or something. So this is Java code for binary search algorithm. We have also C# code for binary search algorithm. So these are the algorithm like snippet. It will not work. You have to put this algorithm within a main method, or you have to call this method, method by a main method, within a main method. Okay, I will show you in a program, real program, but let us finish this. This is Python code. I think you are not taking any Python class. Yeah. So sorting. Okay, sorting algorithm is the process of rearranging the element in a specific order, either in ascending order or descending order. Ascending means from smaller to higher, and descending means from higher to lower. Okay, so I am not a, like for instance, for me, since I am not a native American English speaker, so this is the way how we did remember ascending and descending when we are in our early days. Okay, so we are taught in a way that for A is in ascending order. This means from smaller, A start with from a smaller angle to larger, So ascending means you will start from a smaller and then you will go through larger. This way we remember ascending, the difference between ascending and descending. Otherwise, sometimes we would get confused. Okay. So there are many sorting algorithms, and since still computer scientists are doing research in order to develop better sorting algorithm or improve the existing sorting algorithm. Okay, so if you are interested in, you can do research on sorting algorithms. There are many sorting algorithms. Okay, the common one is called bubble sort algorithm. Okay, we will go through the bubble sort algorithm. It's commonly known as exchange sort. Exchange means we will exchange two elements. We will put the elements in a bubble, within a bubble, and then we will exchange the elements within the edges of the bubble. I will go through this quickly. Okay. So bubble means, actually bubble means, a bubble. So this is a bubble. Okay. Okay. So like this is a bubble. Like this. This is a bubble, right? Like this is a bubble, but for instance, for our needs, for our purpose, we do not need this. For instance, this upper part. This upper part. We need only the edges. We need only the edges. I'm sorry. We need only the. What happened? For our purpose, we only need this part of the bubble. Okay, and there are two versions of bubble sort algorithm. Yeah, please give attention. There are two versions of bubble sort algorithm. They are slightly different. Okay, I will show you both versions. For version A, for instance, we are given a list A equal to A that has 4 elements, 8, 4, 2, 1, and we want to rearrange this list in ascending order. Okay, so then bubble sort algorithm will start from a small bubble. Okay, so it will start from this bubble. We will do 8 and 4. Okay, so it will make a bubble surface that will cover 8 and 4, and it will compare 8 and 4. So since we are doing an ascending order, and then we will compare 8 and 4. If 4 is less than 8, since 4 is less than 8, so this will be replaced. So 4 will come here and 8 will go here. Okay. Then what will happen? So we have 4 here and 8 here. So then we also have 2 and we also have 1. So then what it will make? It will make, in this version, it will make another larger bubble. And at this time, it will compare between 4 and this 2. Okay, since 2 is less than 4, so 2 will come here and then 4 will go there, and then we have already 8 here and 1 there. Okay, and then at this point it will make the bubble even larger, and every time it will work with the element only on the edges of the bubble. not inside, not outside. So this time it will compare between 1 and 2. So then 1 will come here and 2 will go there, and then we will have 8 and 4 inside. So then after the end of first iteration, that will take 4 minus 1 equal to 3 solves. Our array list will be like this: 1, 8, 4, 2. 1, 8, 4, 2. You will understand this? So there the concept is that in version A, it will start from a smaller bubble, and then it will be making the bubble larger and larger. And every time it will check only this element here and here, only this position and this position, only on the edges. Not the elements inside, not the elements outside. Okay, so after first iteration, we will get one element in position, that is 1, first element in position. Okay, so we get this element 1 in position. Then we will make our sublist. Okay, we will change the address. So all arrays started from index 0, right? For next time we will add another 1, increase the index size 1. So then it will go to the next, it will skip the first element and it will start with 8, 4, 2, this. Then it will swap, it will make another bubble that will compare 8 and 4. Okay, so 8 and 4, since so 8 and 4. Okay, since 4 is less than 8, so 4 will come on the left and 8 it will go on the right side. And we have 2 other positions. So we will come 4 here, 8 here, and we will have 2 over here. And then it will make the bubble again larger. So it will make another larger bubble and it will compare 4 and 2. So 2 will come here and 4 will go there, 8 is in position. So at the end of second iteration, our list will be 1. I already have 1. I already have 1 in place. 1, 2, 8, 4. You see that I have 1, 2, 8, 4 at the end of second iteration. And for third iteration, I already got 2 elements sorted in position 1 and 2. Then it will start from, it will compare only 4 and 8. 8 and 4. Since 8 is greater than 4, so then in the another last iteration, 4 will come here and 8 will go there. So I already have 1 and 2, 1 and 2. So I will get 1, 2, 4 and 8. So how many total swapping I need? I need swapping n minus 1 swapping here. That means 4 minus 1 equal to 3 swapping, and here n minus 2. That means 4 minus 2 is equal to another 2 swapping, and I need 4 minus 3 equal to 1 swap here. So 3 plus 2 equal to 5. 5 plus 1 equal to 6. So then maximum iteration I need 6. And in another way you can find the number of iteration maximum. So n minus 1 factorial of n minus 1. N is here number of elements 4. So factorial of n minus 1 equal to factorial of 3 equal to 6, right? 6 iteration you may need. So this is the version 1. So in your slide you have this version, the algorithm you have in this version. But if you do a Google search, or if you go look at other books or some other materials, then you may find another version, okay, the different version of bubble sort algorithm, okay. Although people will not say that this is also a different version of bubble sort algorithm, I remember that way. It is called, I say called version B. I say this version B. I remember this way. So in version B, you say, if you write B in a nice way, that we have 2 equal bubbles within B. right? So that means in version B, your bubbles will be always same size. Bubble will be moving forward, but your bubble size will not be larger, same size. For instance, let us start with 8, 4, 2, 1, and the first bubble, it will compare 4 and 8. This 4 will come here, 8 will go there, and 2 and 1 I have as is. So we are not done in first iteration yet, okay? So then the bubble will be moving forward. So then same bubble will come here, same size, okay? Then 8 and 2 will be compared. So then 2 will come here, 8 will go there, and I already have 1 in position. So then another bubble, the bubble will be moving right forward. And then 8 will be here and 1 will be there, here, and then I have 2 here and 4 here. So this will be the position at the end of first iteration. And at the end of first iteration, we will get one element in position, that is the right element. That is this element. We will get this one element in position. Then we will truncate, we will sync our array from right to left. So in the second phase, we will consider this part, only this part of this array. Remember, compare that from previous version. In the previous version, A version, we got the left element in position, right? And here we are getting right element in position. Okay, then in the second iteration, at the beginning of second iteration, it will compare 4, okay, I'm sorry, 2 here. It will compare 4 and 2. So then 2 will come here, 4 will be here, and then 1 is in position, and then it will make another bubble, and it will compare 4 and 1. So the 2 will be in position. 2 is, let me write it. 2 is in position. 1 will come here. 4 will be there, and I have 18 already in position. So then at the end, after the second iteration, I will get like this: 2, 1, 4, 8. Okay, and then 2 elements are in position. Then I had 3 swapping at the first iteration, 2 swapping in the second iteration, and in the third iteration I will need another 1 more swapping. In the third iteration, it will compare 2, 1. Okay, between 2 and 1. Since 1 is less than 2, so 1 will come here, 2 will go there, and then I already have 4 and 8 over here. So by just this one iteration, I will get this 1, 2, 4, and 8. So I did remember this way. So the second version B, it will have the same bubble, same size bubble size will not be increased, but in the previous version, in version A, bubble will be increased. Okay, this is the way I used to remember when I was a student like you. Anyone has any question? Any thought? Okay, please raise your voice. Okay, so I'm not that I know everything. But whatever in this course, the course content, I know everything. If I wish, I could. If you can, then I can teach in one sitting, from first to last. But that will not help you, right? You have to go little by little. You have to know a smaller thing, then you have to increase. You have to practice, and you have to practice. Okay, so this is the bubble sort algorithm here. So now by comparing the two versions of the bubble sort algorithm. Can anyone please tell me which version do I have here? Version A or version B? How do I know that it's A? Sorry? Yeah. Huh? The clue is here for the inner loop for each j from I plus 1 to n. So the j is increasing, inner array is increasing. That means it is going forward, right side, okay? The left index is increasing by 1. Okay? So the clue is here. From then at the beginning of the second, here, at the beginning of the second inner loop. J equal to I, or in the other version, if you find that in Google, go to Google search and find the other version, the B version, then you would say that here is different. It will stay n minus 1. It will start from n minus 1. B version B, that reduce the array from right, but here in version A, reduce the array from left. So since your slide does not say actually the two version difference, between two versions, just go through this version. Even many book, or if you do internet search, people do not say that there are two different versions of bubble sort algorithm, and this is the different version, then this is the version B and this is the version A. Just I wanted to share you, so in case, so that you do not become confused. Anyone has any question about bubble sort algorithm? So here you see in the within the if body, we are using a temp variable here. Can anyone please tell me why do I need to use this temp variable? Yes, we need to swap because since we are comparing these two values, right? From the edges of the bubble, so we are comparing two values. So we need a temporary variable in order to put the first one in position. Save a copy of the first one. Then we need to, you can use that. So let us do a quick activity. This is called swapping activity. So for instance, I have two. Can anyone please volunteer for me? You wanna come in? Okay. Okay, I have a pen here. Your pen is actually styler, not a pen. Styler, okay. And this is what is it called? Pointer. Both are valuable, okay. Both are valuable, okay. So although few dollars, okay, valuable. So then you have to swap. Okay, take it. But there are few conditions. There are three conditions. You cannot throw on the air, or at any certain time you cannot keep two on your hand, one hand. At no time you cannot, even for a millisecond, you cannot keep two on hand. Okay. You cannot get any help from someone else. You cannot throw on the floor or on the air, or you cannot put on the table. Okay, take these two. Can you exchange these two? Is it possible? So for swapping, I asked him to do a simple thing, right? But I gave them some conditions. So those conditions actually are the built-in condition for variables. Because when you declare a variable, right, what happens? It takes a memory space. And that memory space contains only one value at a certain time. If you put another value of this memory space, the previous value will be gone. You cannot retrieve it, right? So this is why in order to do a swapping activity, you need to use a third variable, right? So, but if I allow you, so you said you failed, right? You cannot do that, right? But if I allow you to ask someone help, then you can do that, right? If I allow you to ask him, can you please raise your hand and help him? Yeah. So then whatever you're doing, okay, then you are giving, yes, do it. Can you please go on the front and show it? Okay, so do it slowly so that everybody can see. Okay, yeah. So you are giving your element to him. Okay, then you have your one hand empty. Then you are putting your right element to your empty hand. Okay, okay, and then you got your right hand empty. Now you are taking that from him. Now you got soft. Right? So the third person here is the temp. Understand? This is the reason we use for any, thank you so much. This is the reason for any kind of swapping activity, we must need to use another temporary variable. Temp, we say usually it's a temp, that because we are using it for temporary use. We don't need this. After swapping, we don't need this. Right? Sorry?
Could you pull up a visualization of it on Google?
Yes. Let me, yes, on Google, if you do a Google search, I will see, maybe I have to cover another slide. If I have time, then I will do that, okay? I have to cover a slide. So bubble sort is straightforward, but if I am asked to sort some element, I personally would select bubble sort. That is quick. We can do quickly, right? We can do quickly. Okay. There is another sorting algorithm. Other sorting algorithms is called selection sort algorithm. In selection sort, so if you want to do ascending order, then you will find the smallest value in the list. Okay, and move it into the first position in the list. Then you will get one element being sorted. Then you will continue this part, this process. Okay, with in the next iteration you will look for the second smallest value. Okay. That means the just larger than the smallest one. It may be the same one, same size, and then you will put that in the second position. In this way, you will continue your selection sort at the end. So, for instance, here I have the original list of 11, 9, 17, 5, and 12. So that if I want to do an ascending order, then what I will search for? 5, right? The minimum on 5. In order to find the minimum one, actually, in this case, you need to use another temporary variable that is called minimum, that you will put very for the minimum point, you will put that very large 9999 something. You will assign with that value. I will go through the program, actually a live program, in order to describe this when I try. So, okay, so in your test, you will be given a data set, and you will be asked to write, okay, what will be the position of this list after the first iteration, like for instance in bubble sort or in selection sort. Okay, so for instance, if you are given this list and you will be asked, then you need to write only these values. You don't need to write any description. You will just write this, and then in the second line you will write this, and third line you will write this, and fourth line you will write this. So this is the working process. Selection sort. Yes. Do you have a question?
That's basically what our test will look like. You're gonna give us a piece of code or a different algorithm. We're just gonna say what it does or specifically like run through each iteration?
Sometimes you may be given an algorithm and you may be asked to trace the code, but you may be given. So I don't know. I'm not sure about the test question yet, but that is a plausible question. In last semester we did have a question like that. So this is the selection sort algorithm, and we have Java code over here, and we have C# code over here. So then Python code. Okay, so now let us compare bubble sort and selection sort. Which one is better? Can anyone please help me? Which one is better, bubble sort or selection sort? So we have to compare this algorithm in terms of their complexity. Complexity means time complexity. How much time it requires in order to complete this process. Okay. Almost all sorting algorithms takes big O of n squared time. So big O of n squared means, so and you remember that in worst case big O n squared. For instance, if okay, for a short number of lists, very small list, we will not realize the effect of big O n squared. But think about that, if n is very large, 1,000 or million, right? Then what number it will be? 1,000 squared. That means 1,000 times thousands, right? 1,000 will be go 1,000 times. Very, very large time. 1,000 times 1,000, right? Very, very many iteration it will need. So compared to where we study searching and sorting algorithm together at a certain time, then definitely we compare that all searching algorithms are very easier in terms of complexity than sorting algorithms, right? Okay, go through this slide please, and let us see that. Okay, there is another sorting algorithm. We will go through this. It's called insertion sort. Okay, insertion sort, like some actually like people when they play with cards, and then for instance when they get first 4 cards or 1 card, for instance when someone shuffle and distribute the cards, he put one first card maybe on hand, and then when he gets second card, he put either on left or right, and when he gets third card, then when he looks, he compares that whether the third card's value should go in the right side or left side, right? Greater than or bigger than. This is the process of insertion sort. People usually, even people who do not know this name, this terminology, even illiterate people who play with cards, right? Then they know this insertion sort algorithm, this process. So actually in insertion sort algorithm, one thing to remember that you continuously maintain 2 sets. One is unsorted set and another is sorted set. For instance, if you have a card, unsorted, if you put on table, and then you pick one from the unsorted list and put in the sorted list in sorted manner, right? So every time you are growing your sorted list and you are shrinking your unsorted list, right? By the end of this process, your unsorted list will be empty and your sorted list will be completed or full.
Doesn't it require more memory than the other two algorithms? Because you have to allocate for two.
It will. The difference is that it will need another array, another set.
So it'll take more.
Yeah, it will take not in that sense more memory. It will take another same size. You have to expect that if you have a first array of 1000 size, then you have to declare another array of 1000 size,
Yeah.
same size.
Versus just
Yes.
using a temporary.
Yes. The temporary variable that use only one variable to swap element. Okay, good idea. Thank you. So this is a process of insertion sort algorithm. So every time what is happening? For instance, I have my empty list first. Then when initially I will get 4. Then when I get the next element 3, then if I compare that 3 is less than 4, so 3 will come on the left and 4 will go right. So then I will have instantly 2 elements sorted. And then when I get 2 is less than both 4 and 3, so then 2 will come all the way left. And for the 10, since 10 is greater than 4, 10 will be one place. And again when I will get 12, since 12 is greater than 10, so 12 will be one place. So then at this position, after when I get 1, after 12, since 1 is less than all of this, so 1 will be comparing here. So this array, this element, and then it will be all the way end. For instance, if I would get an element 5, that will be in between of these some elements. So then 5 will be first compare with 12. Since this is less than, it will compare again with this 10 with 10, and then it will compare with 4. Since 5 is greater than 4 but less than 10, so it will be sitting in between 4 and 10, like this way. Let me see. I have this is the working process of insertion sort algorithm. So please go do this practice this at home, so that you can do if you are given a set of data like this, you can do that. So this is the insertion sort algorithm and Java program and corresponding C program, C# program, and Python. This is sorting code. We don't need Python. Okay, so let me go through the next slide. Let us see what I do have. So for implementing searching and sorting algorithms, we need array. We need to use at least one-dimensional array, okay? Or you know about two-dimensional array, right? The two-dimensional array or one multi-dimensional array. Two-dimensional means, so for instance, if you have elements in a row by column order, in a tabular form. So if you have an element in a tabular format, let me show you some elements. Is this my code? These slides are not sufficient. Okay, so let us go through this. So if I have a table like this, some rows and some columns, okay, then if I put values over here like 1, 2, 4, 6, 5, 3, 2, 9, 7, whatever value I need, 2, 0, 1, okay, 0, 1, 0, 1, for instance. So these values are presented in a row and column position, right? So then we have cell by we will go first row 1, R1, R2, and then R3, and then R4, and this is our column C1, this is C2, this is C3, and this is C4. Okay, so when as a human being, when we try to trace a table, we start from row 1, row 2, row 3, like this way. But in computer memory, in computer program, when we want to do this, okay, so then we will do this one R0. We will start our index from 0. Then the first row we will say 0, then second row we will say R1, then third row we will say R2, and then fourth row we will say R3. Similarly, the column we will say this one R0, this will say we say R1, this C1, C0, C1, C2, and C3. Okay, then we will get the index of this cell. Okay, 0, 0. This is the position of first cell. And for instance, the position of this cell will be 0, 0, this one is 0, 0, 0, 1, 0, 2, 0, 3, 0, 3. Actually, it's represented by square bracket. Okay, so people who are taking C# lab, okay, there is a slight difference, there is a difference between two-dimensional array declaration in Java and C#. In Java, you see the let me see actual code over here if I do have. Okay, so in Java, you see that this is integer 10, 20. These 10 and 20 are put separated within separate square bracket. But in C#, what you will do in C#, you will put this in one. Here, you see in the C#, you will put this in within one set of square bracket, but you will put comma inside. But in Java, you see the difference here. This first value is for row and second value is for column, and for first value is for row and second value is for column. So for your test, okay, I'm looking out a possible question. You will be asked to trace or write a pseudocode using a two-dimensional array. Two-dimensional array, okay. So do some practice in programming. For instance, if you are asked to find the largest even number, that numbers need to be largest and even from a two-dimensional array or a table. Table means two-dimensional array, right? That element will be, for instance, largest. It must be the largest among the even numbers. Okay. Or if you can do this, then you can do anything. Largest even, largest word, smallest even, smallest word, right? So if you do practice one of these, then you can do whatever is asked. So for a two-dimensional array, in order to access two-dimensional array, we need two inner loops. Two loops. One inner loop inside another inner loop, but for it, this is a three-dimensional array. Okay. For instance, it may be length, height, and weight. For a three-dimensional array, you need to have three for loop. So as many dimensions, you need that many of loop. So here, in next class, do I have time? How long I do have? 12 minutes? Okay, maybe I can go through a real program. I have some programs. Oh, sorry, before I go to the program, so I need to give some coverage about object-oriented principles. So maybe in the first class I discussed object-oriented principles. That means the foundation of object-oriented programming is what? Class, right? Class is a data type. Okay, and then a class is declared or a class is created in order to create what actually is called define, not create. In order to define any number of instance of that type later whenever you need it. Okay, an instance of a class is called an object. So object and class are the foundation of object-oriented programming. Then when you understand, if you understand a class, then you will understand that a class contains some variables and some methods in order to access those variables. The variables of a class are called the actual field that contains the attributes of that instance, an instance of that kind. Okay, and a class should contain some methods. That methods are used to contain those, to access those variables. Okay, when we discuss about constructor, a constructor is a method that has same name of its class name. A constructor cannot return any value. A constructor cannot be called explicitly. A constructor is called with a new operator only at the time we declare or we create a variable. Okay, go through these basic principles of object-oriented programming, whatever you learn in your first course. So let me go through. So you see, these many programs I discussed in my last semester. So, and I will go through all of this here again. So the array, so two-dimensional number array. Okay, so I have an array. So if I have an array of two-dimensional in Java code, okay. So this you see that I need two of this, two square bracket. Actually, this will indicate that you have a two-dimensional array. So in the two-dimensional array, that means you have to, when you assign values, then you have to put these values within second bracket, and then within second bracket you see we have another set of second bracket separated by comma. And within this individual second bracket, I have the actual values of this. So actually, if I trace out this two-dimensional array, then it will be like this: 5, 7, 4, 7. I'm sorry. Then again 7. Oh, sorry. This will be 5. Sorry. It's gone. So my first row is 5, my first row is 5, then 7, then 4. Second row is 5, 7, then 7. Third row is 3, 1, 0. Right? So actually the implementation will be this. Okay, and this the position of 5, this is 0, 0. The position of this 7 is 1, 1. This 7 it will be 1, 1. And this 4 will be 0, 2. Let me see what does this program do. So in this program, I will check whether 11 is available or not. An element 11 is available or not in this program. So let me run this program quickly. What is the result of my quick run? Computer is slow. I'm sorry, it's showing me. Okay, it's showing me number 11 is not found. Okay, and then if I search for 3. Okay. Sorry, why it's showing me 11? Okay. I'm sorry, why 3 is not found? My number 3 is available there, right? Okay, so I have a condition over here actually. It says grid is okay. So actually it is finding me. It's a number. Maybe later I change this. If a number is also even, I don't need actually this. Okay, 3 is found one time. Okay, so if I want to search for 7, the 7 is found 3 times, right? Okay, if I want to search for 5, then 5 will get 2 times. Okay, so in this program maybe I try to explain something. So if you are asked to find the lowest number or in a specific number that is even integer or word, then you may need to add some code over here, on this line, like and with an condition. For instance, this is for integer, for even is divisible by 2. Okay. So I am pushing this code. I will push this code in the GitHub. So in your project, so that you can get it. So you are in section 3, right?
Yes.
Okay, so then I will create a package. I will create package. That means we put our program separate.